So the next topic under our discussion is position of elements in periodic table. If you take position of elements in periodic table, here the elements position depends on the electronic configuration of elements, and this electronic configuration should be in the form of differentiating electron, that is the last electron of element. So for example, when you say position of the elements in periodic table, we can take that is position of elements depends on that is blocks of periodic table. So when you say blocks of periodic table, here blocks of periodic table is made up of S block, P block, D block, and F block elements. So if you go for S block element, example, we can take that is 1A group. I am taking 1A group sodium and 2A group that is magnesium. Why the sodium and magnesium of 1A group and 2A group belong to S block? Because the last electron of sodium, that is the 11th electron of sodium, and the magnesium, if you take the 12th electron of magnesium, because sodium atomic number is 11 and magnesium atomic number is 12. So the 11th electron of sodium and the 12th electron of magnesium, they enter into their respective s orbitals. So that you will come to know when you write the electronic configuration. If you write the electronic configuration, if you take sodium, this is the expanded form of writing the electronic configuration: 1s2, 2s2, 2p6, and the last electron is 3s1. I am underlining the 11th electron into which the orbital is assigned. For sodium, the 11th electron is 3s orbital. Similarly, if you go for magnesium, atomic number of magnesium is 12. So 1s2, 2s2, 2p6, 3. This is, here we have 11 electrons and here we have 3s2. That means the last 2 electrons of magnesium are being filled in 3s atomic orbital. Hence it is proved that both sodium and magnesium, they belong to S block elements. Similarly, if you go for P block elements, example, we can take third A group, that is, you can take aluminium. Fourth A group, you can take silicon, and fifth A group, you can take phosphorus. Sixth A group, you can take sulfur, and seventh A group, you can take that is chlorine. So if that is the case, if you take aluminium with atomic number 13, you can take 1s2, 2s2, 2p6, 3s2, 3p1. 13th electron of aluminium is being entered into 3p orbital. That is why we can say that aluminium of third A group belongs to P block. Similarly, if you go for silicon, atomic number 14, you can take that is 1s2, 2s2, 2p6, 3s2, 3p2. You can see that in the case of aluminium, the last electron, the differentiating electron, is entering into the 3p orbital, And in the case of silicon, again the last two electrons, they are entering into the last two electrons, that is the differentiating electron, the last two electron and the 14th electron of silicon is entering into the 3p orbital. That is why we can say silicon belongs to p block element and aluminum also belongs to p block element. Likewise, you can go for, that is sulfur. Sulfur, if you take 1s2, 2s2, 2p6, 3s2, 3s2, 3p. Already we have filled up 10 electrons, 10 plus 2, 12, 12 plus 4. You can see that 16th electron is being entering into the 3p orbital. So likewise, you can go for even that is sulfur atomic number is 16. So you can go for the electronic configuration of chlorine also. Chlorine atomic number is 17. So 1s2, 2s2, 2p6, 2s2, 2p6, 3s2, 3p5. That means the 17th electron of the chlorine, differentiating electron, is entering into the p orbital. The 16th electron of sulfur is entering into the p orbital. That is 14th electron of silicon is entering into the p orbital, and 13th electron of aluminum is entering into the p orbital. That means the differentiating electrons, that is the last electrons of each and every element, is entering into their respective orbitals. So based on the entering of the valence electron or the last electron, that is the differentiating electron, into its respective orbital, we can decide the element belongs to that particular group or that particular block